Hi everyone, this is our reading and note section for pages 275 and 276. And the section that we're talking about actually starts, you can see in your book on page 274. So when I go to set up my notes here, I'm going to take my section title because everything that we're going to be talking about here for the next week or two is going to be all about how we measure matter. So let's go ahead and go over to our notes. And so today I've added measuring matter as my big heading, and my date is 10/30/13. Now, this is a great warm up for my brain. I know that everything that I talk about in this section is going to be a measurement. So if I go over to 275, which is where we're going to start our reading for today, I'm previewing and I see what units are used to express mass and volume. So I know that in this reading here, I'm going to be dealing with some units. Right now, take a moment, pause the video, and think about what units of measurement have you worked with before. Good. Now, moving on, I see the red mini subheading weight, and I also see that weight is going to be a vocabulary term. And I see some pictures of fish on a scale. And on the next page, I see mass, and I see that mass is also the vocabulary term and the International System of Units. Now, I see mass and weight are the two things that I'm primarily reading about today. So I want you to pause the video and think, what do you already know about weight, and where have you heard mass before? Here's a hint. Think about your definition of what matter is. Okay, now that we're back, let's go ahead and let's start reading. What units are used to express mass and volume? Here's a riddle for you. Which weighs more, a pound of feathers or a pound of sand? If you answered a pound of sand, think again. Both weigh exactly the same, 1 pound. There are all sorts of ways to measure matter, and you use these measurements every day. Scientists rely on measurements as well. In fact, scientists work hard to make sure their measurements are as accurate as possible. So our first measurement that we're going to talk about is weight. Your weight is a measure of the force of gravity on you. On another planet, the force of gravity will be more if the planet is more massive than Earth and less if the planet is less massive than Earth. On the moon, you would weigh only about 1/6 of your weight on Earth. On Jupiter, you would weigh more than twice your weight on Earth. To find the weight of an object, you could place it on a scale like the one shown in Figure 1. The object's weight pulls down on the mechanism inside the scale. These mechanisms cause beams or springs inside the scale to move. The amount of movement depends on the weight of the object. From the movement of the beams, the scale displays the weight to you. So, what we have here, the first thing that we need to talk about is what is weight. And we said that this whole section is going to be on measurements of matter, but weight isn't necessarily measuring matter. Weight is measuring the force of gravity. So let's add that to our notes right now. So my first term is weight, and that is the measurement of the force of gravity on an object. And if we go back to our reading, let's move on to our next little area in our paragraph. It's talking about how on other planets we would weigh differently. And we talked about this in class, how the amount of gravity on Moon, which is smaller, is going to be less. And the amount of gravity on a planet like Jupiter is going to be more, so we would weigh more. Do you remember what we said about what we would weigh in space? So if we go back to our notes then, we can add that weight changes depending on your location. On planets more massive than the Earth, we would weigh more because there is more gravity. Or you could say on planets less massive than the Earth, we would weigh less because there is less gravity. Oh, and I just saw that I misspelled weight, so I'm going to go up there and fix that mistake there. Headed back to our reading. In the second paragraph, it talks about how we are going to be able to find the weight of an object and the tool that we use. And it says that the tool that we use is a scale. So we're going to go ahead and add that. The tool we use to measure weight is a scale. Now, in the book, I have a slight issue with our book because it shows it to you in kilograms. Now, we know from class that on our spring scale, the unit that scientists use to measure weight is actually the Newton. So we are going to go ahead and add that. And our abbreviation for Newton is a capital N. Has to be capital, that's important. Good. Now let's go back to our reading here. And that's all we have on weight. So if we flip our page over to mass, let's start reading. And I see that this is a large chunk of reading, so I'm going to read the first paragraph and look for important information to add to my notes, and then I'll go and read the second paragraph. Mass. How can you weigh less on the moon than on Earth when nothing about you has changed? Your weight is dependent on the gravity of the planet you are visiting. The amount of matter in an object is its mass, which does not change with location, even if the force of gravity changes. If you travel to the moon, the amount of matter in your body, your mass, does not change. You are the same size. For this reason, scientists prefer to describe matter in terms of mass rather than weight. The mass of an object is a physical property. So let's go ahead, and I see that mass is my vocabulary term there, and I'm going to go ahead and add mass to my definitions. If it'll let me pop that up, we can add it. There we go. Now, I'm not talking about weight anymore, so I'm going to move my bullet point back out to the margin, and we're going to add mass. And it is the measurement of the amount of matter in an object. Good. So let's go back and double check to make sure that there's nothing else from that paragraph that we need to discuss. And one important thing is now they're comparing weight and mass together, and we're saying that no matter where we travel, our amount of mass does not change. So we can add mass does not change based on location. So because of this, scientists prefer to use mass instead of weight to measure matter. Good. Let's go back now and read that second paragraph. To measure the properties of matter, scientists use a system called the International System of Units. The SI unit of mass is the kilogram. If you weigh 90 pounds on Earth, your mass is about 40 kilograms. Often, a smaller unit is used to measure mass, the gram. There are 1,000 grams in a kilogram, or 0.001 kilograms in a gram. The table in Figure 2 lists the masses of some common items. So you can see the masses down in Table 2 of a nickel, a baseball, a pineapple, a full can of soda, and an inflated balloon. Let's go ahead and finish up our notes. So, scientists use the International System of Units, or SI unit. And then underneath our talk of what an SI unit is, we're going to list our SI unit for mass. The SI unit for mass is kilogram. and the abbreviation for kilogram is kg. We also use gram, which is G. In your book, I think it's interesting, they don't talk about the tool that we use in order to measure mass, but we talked about that in class. So let's add that to our notes. So not talking about the SI unit anymore, so now we're going to say the tool to measure mass is a balance. Very good. You have finished your notes for pages 275 and 276.